That's your seat over there.
John's here.
No, you sit over there.
Jonathan, you're over here.
Okay, okay.
Lauren, catch you up. Alright, give me a second to get attendance put in here. Jackson, you're up here. Alright. Welcome back. It's been a full week since I've seen you guys, but we need to pick up where we left off. So I'll start off by reminding you what we did last class. So what we're doing today is similar objective, but a different strategy to get there. So last Thursday, we started our law of sines, law of cosines unit, which is very short. Again, we really only spent a few class periods on it for your sake, for the ACT, but we focused solely on law of sines last Thursday. So, law of sines had a certain formula to it. It helps you find side lengths and angle measures of any kind of triangle. It doesn't have to be a right triangle. It can be an oblique triangle. Sorry, this is the one y'all need. I had it on the wrong slide. So today we're going to do the other half of that, which is law of cosines. So law of cosines works for different information. It's got different formulas involved. So law of sines worked anytime you had two angles and a side, like angle, angle, side, angle, and side, angle. Whereas law of cosines, you'll see, works for side, side, and side, angle, side. So if it did the exact same thing as law of sines, we'd only need to learn one of them. But some different formulas involved with those. If you don't remember, I told you that in this unit, we don't spend very long on it, but we don't make you memorize any of the formulas. So it's probably a good idea to be very familiar with them so that you can recognize them on the ACT. But for our quiz, you don't have to worry about memorizing them. So our plan today is to get comfortable with the law of cosines. So we'll do handout 60, talk about the notes, and look at a couple quick examples. Also, 61 should be able to be done in class, because there's only 9 questions there. Both those can be turned in before you go, and then you can start the worksheet that you picked up, 62. It's also short. I think it's like 5 questions or something. But you don't have to have that one turned in by tomorrow. Assuming we have school tomorrow, I obviously don't have any insight to that, but assuming we have school tomorrow, that would be our review day. So I have a review worksheet that scrambles the questions together. Some of them are law of sines, some are law of cosines, and it forces you to think about which one to use. And then the next class, which would be next Tuesday, again, assuming that snow doesn't mess anything up, will be the quiz on that.
Okay, so tomorrow's a review day, not the 112 quiz it says up there.
Yes, I apologize. I did not change that. Anytime I put dates over here, that's always tentative anyway. That's like what we're aiming for. And I try to update it when stuff happens and I forget sometimes. Yeah, so assuming no snow, tomorrow will be a review day to kind of pull it all together, and then the next day will be the quiz. So you don't have to worry about studying it now. All you need to worry about is the law of cosines today. So even though we will provide the formulas for you, we will ask you, when can you use the law of cosines? So if you have all three sides, side, 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 you could use one of these three formulas to solve for an angle measure. And if you have side angle side, which means you have two side lengths, and you know the angle trapped in between those, known as the included angle. You need to know that term. Then you could use one of these to solve for a side length. So, side angle side, 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 side. Again, law of sines that we talked about last class did not work with side, 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 nor side angle side. So really same objective, but it works for different information. Also, I'm sure I'll have the agenda slide back up in a little bit, but I feel like before we get too engrossed here in the questions and the process and all that kind of stuff, I feel like it's worth mentioning, especially this one here. This one should look pretty familiar to you. What does that look like? Right, so the first part, you've got a squared plus b squared equals c squared, which would be Pythagorean theorem. But Pythagorean theorem only works on right triangles. If you do the minus 2ab cosine of angle c, now it works on all triangles. So, of course, I have no input in what gets taught in geometry, but I always wondered why they didn't make you do this instead of Pythagorean theorem, because this always works and Pythagorean theorem only sometimes works. What happens, and why I want to focus on this one for just a second, when it is a right triangle and this angle is 90 degrees, what is the cosine at 90 degrees?
One.
The cosine of 90 degrees is 0. So if it's a right angle, all of this goes away and you're left with Pythagorean theorem anyway. So it's like a more complicated but also more versatile Pythagorean theorem. Okay, so let's look at a couple of examples here. Example 1, this is just a picture I stole off the internet, but this is somebody using the law of cosines to solve for an side length. So notice they had a side, then an angle, then a side. Side angle side is why law of cosines works. So they wrote down the formula that's at the top of your page. They plugged in the numbers. I feel like you could probably skip all of this, and you're going to have to use your calculator anyway, so why not just use your calculator and go down to the end. Of course, at the end here, to undo the square, you'd have to take the square root. But if you know the formula, or in our case for our class, we provide the formula for you, really you just have to make sure you plug in the numbers correctly and make sure it gets plugged in the calculator correctly. All right, Jack, when you want to put that up to join us? Thank you. And then example 2, here's where they're finding two angles. So notice a couple versions of the formula. The numbers plugged in. These numbers will be something from -1 to 1 because that's as big or as small as cosine can be. So just like with law of sines, to go from cosine of an angle equals to just the angle equals, you need to do inverse cosine of that ratio. Make sure that you don't think that this is the angle. That's the cosine ratio, not the angle. Okay, but the specific numbers of that question are not that important. Okay, we also squeeze in one more area formula here, and then we'll practice a couple of these before we move over to the book assignment. So last time I reminded you that you knew this area formula for a triangle from geometry class, 1/2 base times height. And then when we did law of sines in section 6.1, I said there's 3 others that you can use if you have side angle side. That would be 1/2 times 2 sides times the sine of the angle in between those. Once again, you don't have to memorize the formulas, but I have seen this on practice ACT tests, so it might be beneficial for you to be able to recognize it. The one that we squeeze into this section, 6.2, is called Heron's formula, and this is a very famous formula. This one shows up on like lots of math competitions and stuff. This is also something I'm kind of surprised they don't teach you in geometry, just because it's very useful and not hard to apply at all. But Heron's formula says if you have all 3 sides, you can find the area of any triangle doing the square root of s times s minus a times s minus b times s minus c, where s is where you add the lengths up and divide by, what would you guess to divide by here?
3.
Okay, 3 is a good guess because that's what it would be if it was an average, but it's not 3, it's 2. S is for semi-perimeter. Just like a semicircle is half a circle, semi-perimeter is half of the perimeter. And that works for any triangle. If you know it's 3 lengths, calculate S, plug it in here, 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 and here. Plug in 1 length there, 1 length there, 1 length there, and you get the area of any triangle. We'll practice one on the back page.
Wait, it's S, or it's 5. Is that an S or a 5?
These are all S's.
Okay.
Sorry, my S's and my 5s are very similar. Okay, so before I do one law of cosine example for your notes and one Heron's formula also for your notes, on the back page, I don't know, I used to teach a lot of geometry, so this is kind of important to me. I think it's good for y'all to hear it anyway as a reminder because it's been a couple years for most of you guys. But just because you're given 3 lengths, you can't make a triangle out of just any 3 lengths. If I told you A was 10 meters and B was 3 meters and C is 13 meters, do you see how it would like, C would basically have to be on top of A and B like this, and you're not really getting a triangle? That's the only way for them to connect. So you can't just make a triangle out of any lengths that you want to. The thing that you should have learned in geometry, I don't know if you remember it or if you did learn it, but for a triangle to exist, the 2 smaller sides have to add to be bigger than the biggest side. If they're not, this is an example of where they're equal. I could make those line segments connect, but it wouldn't be a triangle because there's no, I don't need to push any of those up to make them connect. That doesn't really apply to this unit. I just like to remind you of that. You did, does anyone remember that from geometry? You do? Okay, good. Okay, so now here's one that we can actually use the law of cosines for. So, just like law of sines, if it makes you feel better, feel free to sketch a triangle. It can be a generic triangle. You can see my angle C is supposed to be obtuse, so I didn't make it look obtuse, but if that makes you feel better, then you can see I've got a side, and the angle in between those. Side angle side is one condition for law of cosines. So I need to find angle A, angle B, and side C, and you can try to find angle A or angle B in law of cosines, but law of cosines can only find you an angle measure if you know all 3 sides, so you can't do those yet. You're going to have to do one of these first. So that one says you could find a side length. So like c squared would be equal to a squared plus b squared minus 2ab cosine of angle C. And then you just plug in A where it's supposed to go, plug in 86 for B, plug in A a second time and B a second time, and then plug in the angle opposite the side you're trying to find. But assuming that you plug those numbers in the way the formula tells you to, and assuming your calculator's in degree mode, because this is 105 degrees, you should be able to just type it in. Hit enter, and you have side C at that point.
Could you also use Heron's formula? to get
Heron's
that?
formula helps you find area.
Oh, so you're not gonna get a side out of that.
Yeah, you're not going to get sides or angles out of that. Okay, now I know all three sides. And again, I did round this. Sorry, this is a 4. I round this for my paper. But you either need to keep up with all 8 or 9 decimals, or you can store it using the store button in your calculator. But now, maybe to find angle A, I could look up one of the other formulas, and there's one that says cosine of A equals. So my preference is, just like this formula, I went ahead and did the square root at the start, because sometimes you guys forget it if you do it at the end. I would suggest the same thing with the angles. Do inverse cosine at the beginning instead of the end. And then this formula should say like b squared plus c squared minus a squared over 2bc. And we have all that information. So let's plug that in. Okay. I'm writing C, but remember my calculator knows exactly how big C is. So B and then C. Now this one we need to slow down for just a second, because this is where you might have a problem depending on how you type that in the calculator. If you type it in your calculator correctly, you're finished with that part of the question. But let me go ahead and do that while y'all finish copying that down, and I will show you what I'm afraid you're going to do. And I don't want you to be confused if this happens to you. So okay, so I typed it into the calculator that you could see. So if I'd asked you to type this in the calculator, I suspect several of you would do it this way. And if my calculator gives me a number here, which it probably won't, it'll probably be an error because there's something going on in here. But even if it does give me a number, that number's not going to be correct. Again, I did store the value of C in, so that's not the problem. So, what's wrong with this versus how we wrote it on the paper? Okay.
On there, you're only dividing by 2. You need to divide by 2 times 87 times C.
Right, so your calculator does order of operations very, very strictly. It's going to do the exponent stuff, which is fine, but then left to right is going to do division and multiplication. So it's going to divide these numbers, whatever they are, then it's going to multiply that times 86, and then it's going to multiply that times C. Then it's going to go back and do adding and subtracting, and that's not what you intend for it to do. So what you have to do is you got two options. You can either put your denominator in parentheses to make sure it computes all of that stuff together, and your numerator in parentheses. Because in mathematics, when we write a big fraction, it's actually implied that we do all the numerator stuff first, all the denominator stuff second, and then we divide them. It's implied parentheses. We just don't write them when we do a big fraction. But if you want to do it that way, it's fine. There's the answer to that part of that question. 38.287. 38.287 degrees. Bless you. Bless you. Yeah.
Whenever I solved for sum C, I kept getting 137.25 instead of that, and then that like kind of threw off our final answer because I got 37.75.
Oh.
But I put it in like the same exact way.
I have a mistake on here. You wouldn't see what my mistake was, but remember when I said if your calculator's in degree mode, this would work? The calculator I was typing it in on the side here is in radians, unfortunately. So in calculus, we do everything in radians, so I have to switch it back and forth a little bit. Sorry, so this was supposed to be 137.251.
That's what I thought.
Yeah, thank you. So it's not a big difference, but it's enough to make a difference. And so then this guy, let's fix that. Here's what C is supposed to be with all the decimals. Okay, and then type it back in. Okay, so angle A was actually supposed to be 37.754. 37.754 degrees. Okay, so I said there's two ways to do this. That's one of the ways, putting parentheses around your numerator and denominator. And in fact, that's a good habit to get in anyway. Even if you have a fraction that doesn't need it, like 2/4, I think you should know that reduces to 1/2. But if you want to put parentheses around the numerator and parentheses around the denominator to feel safe, it's not going to hurt anything. But sometimes you will get it wrong if you don't do it. Your other option is you can do alpha y equals option 1. Alpha y equals option 1. And if I didn't really use that much until last year, but if you use this, it allows you to type it in as one big fraction, which is what it's going to look like on your paper. So notice how these are the same. So you can take your choice. Parentheses around the numerator, parentheses around the denominator, or alpha y equals 1 to type it in as a fraction. It understands to do this stuff together and then do that stuff together. It's got the implied parentheses there. Okay, and then to finish this one up, I need one more angle, angle B. So if I look up the formula on the top of the front page, it's going to say cosine of B equals, which means B is the inverse cosine of, and that one's going to be, I'm just going to go ahead and put the numbers. If I'm solving for B, I should need an A squared plus a C squared minus B squared over 2AC. So again, I just have the formula memorized, so it's not too bad, and I'm plugging in the numbers. Everywhere there was an A, I put the length of A. Everywhere there's a B, I put the length of B. Everywhere there was a C, I'm writing down C, but my calculator has that stored in for me.
How did you get it to have it stored in for you? Did you go before and say C equals whatever?
Okay, so when you do this, right above the on button is the store button. So if you click that, you can store it in for any of these letters you want to. So you could store it in for X if you wanted to, but in this case, sometimes you might want to store more than one thing. So I just stored it in for C because it was angle C, and that's easy to remember.
Okay.
And so then anytime I say angle C, it knows exactly what angle C is. It's not been rounded to just a couple decimal places, which is incorrect. And that's it's a lot easier than typing all 8 or 9 decimals in multiple times. So keeps it exact without getting too cumbersome. Yeah.
Couldn't you just do 105 plus?
Yes, but I'm not there yet. Okay, so I did this, or I'm sorry, I did not do this. I'm about to do it in my calculator, but again, as long as you look up the formula correctly, you plug in the numbers correctly, your calculator needs to be in degree mode. Learn from my mistake there. Looks like angle B should be about 37.246 degrees. Now, if I had forgotten to change my calculator to degree mode, I would have caught it here. So I'm going to tell you something that's optional, but I think that you will appreciate it. Okay, so Jack, what were you about to say about angle B here?
I was about to say that all the angles in a triangle add up to 180. So you could just add 105 plus angle C, and then 180 minus that, and then get the answer.
Right, so once you have two angles, you can really just subtract those from 180 to find the third angle, right? But the benefit is, if you're willing to do law of cosines one more time, you've got to check. And this is where I would have known something was wrong. I could have, now that I've done law of cosines twice, I can take the angle they gave me, plus the angle that I got for A, plus the angle I got for B, and it will come out to exactly 180 degrees. And if y'all hadn't told me that my answer was wrong and I was in the wrong mode, it would not have added to 180 and I could have caught that. Whereas if you just subtract 2 from 180 to get the third angle, you're not going to catch that. So there's a little bit of benefit of forcing yourself to do law of cosines the last time. Gives you a little bit more of a catch. Okay, so fairly complicated formulas, but since you don't have to memorize them, we're really just going to practice plugging in the numbers and coming up with the values. And of course, I could write all this stuff on my picture here, make sure the biggest side's opposite the biggest angle, etc., etc. Okay, and then one example of Heron's formula, so we can move on. So this question gives me a side length, and a side length, and that's what Heron's formula is good for. It says you can take square root of s times s minus a times s minus b times s minus c, and s is where it is the semi-perimeter. So add all the lengths up for perimeter and divide by 2. Don't divide by 3 because it's not an average. Semi means half. This ends up being 23.5, and so that's going to get plugged in 4 places, but otherwise that's what I would type in my calculator. Square root of 23.5 times 23.5 minus 16 times 23.5 minus 22 times 23.5 minus 9. Enter 234.405. This is an area, so that it should be feet squared. Very easy formula to use if you know it exists and you know what it is. We will also provide this formula for you on the quiz. You don't have to feel like you need to memorize it, but okay, so your bookwork's going to have a couple Heron's formula to make sure that you can apply that correctly, a couple solving, like question 2 on the back here to make sure you can find sides and angles with law of cosines. And then there's, I don't know, a couple application questions. But if you would, go ahead and on a blank piece of paper, or I guess you can use the back of one of yours from last time. I've got 9 questions for you there. So again, you really only have to do each thing a couple times to kind of figure out what's going on. There's not a lot of variation with these questions. And you got about 62 minutes from now. So again, I don't know how you could not finish the bookwork. Even if you need help with a few of them, I think you should have that finished and in Google Classroom before you leave. And then quite a few people from my 8A classes were also able to do the worksheet and not have homework. So if you don't finish that in class though, you can do that one for homework. But the bookwork and the notes should be turned in. So let me give you guys about 15-minute head start so you can try a few, see how it goes, see if you've got any questions, and then we'll address your questions up on the board.
Those were pretty intensive.
It was good. How was yours?
It was alright. I got to play a lot of video games.
You kind of extended yours.
On Thursday?
Yeah.
Yeah. Because I got scared from the bump, right? And my dad's work was also bombed, or like threatened to be bombed. And so, you know, my mom kind of pulled me back.
I see. I was talking to Miss Bone a few days ago, actually last week, I think before y'all came back from your break. We had one teacher work day, and I think she was saying they're going to start teaching law of sines and law of cosines in geometry. I think they're supposed to teach it in honors geometry at least. So if y'all have any siblings taking honors geometry this year, there's a good chance they will also be doing law of sines and cosines. So you might need to help them out.
Wait, if they're taking it this year,
Hmm?
they're gonna do it. Okay. My brother's in honors geometry.
I don't know when, like I don't know if it's like in the next few weeks or at the end of the semester or what, but
Okay.
she said they were going to do it this year with honors, so.
Nice.
And again, I know I've said this 100 times, but we only do this because it shows up on the ACT a lot. I think it shows up about every other time. Of course, it's only one question, but hopefully you guys will recognize it when you see it now.
Actually, I think the last time I read it was when I saw Heron's Law. If I knew what it was, I would have gotten it right.
Oh, okay. See, I didn't know that showed up on the ACT.
Oh, I saw it the other day.
Yeah.
Are there any more calculators?
Yeah, those two. Those should work fine.
Okay.
Make sure it turns on okay. Sometimes they... Is anything showing up on it?
Which-
Yeah, it should be fine.
Okay.
If it's not, I've got some others you can use. anybody need me to come by and help out yet? Okay, but that's not, you're not solving for A, you're solving for cosine of A. So now do inverse cosine of that.
Oh,
That's why I do it at the beginning, so I don't do it.
okay,
So,
Did you get it, or did you work?
I'm trying to
Yeah,
find
I got
the
that one.
angle of angles right now. And,
We're just looking for the area?
on the equation, it says b split plus b split minus a split. I did
So
that,
what's
and it gave me a
I
really
think
weird
just
one.
what it was, we can solve with what information given, so.
Because this is what cosine of A equals, not what A equals.
That's what Max
Oh,
said.
so,
See, look, this isn't A, this is cosine A. So now you need to do inverse cosine.
okay,
That's
so,
this.
thanks.
That's why I do it at the beginning. I do the inverse cosine.
So for this one, number 9, we're doing kind of the same thing we did here, but obviously it's all so that we don't have it done. And this one is same kind of.
Yeah, you've got
formatting.
side, angle, side. So you could use one of those formulas to find the side length.
Okay.
And then once you have all three side lengths, just like we did here, you could use one of those other formulas to find an angle.
Okay, so find the exact that thing we found here, you know,
Mhm.
okay.
Yeah, if it says solve the triangle, it means you need to find everything.
Okay.
You need to find all the missing sides and all the missing angles.
Okay.
Once you get a few questions in.
What about this number 5 where we were given 3 side lengths, is it just find the area like we did here, or?
No, so it wants you to find all the angles then.
Okay,
Which is
gotcha.
the thing.
Okay.
But on law of cosines, if you have all three sides, then you can use one of those to find an angle.
Okay, gotcha.
So you're gonna have to use that at least twice, and then subtract those from 180, or just do it 3 times to make sure they add up.
Okay, so not just that one from.
Heron's formula is only if you want area.
Gotcha.
That's not gonna be till like the third or fourth question.
Okay.
So I was trying to do this number 5 and I plugged it in for the triangle A. and-
Yeah, but this is what cosine of A equals, not what A equals.
So what do I do once I get cosine of A? How do I know the area?
You can do inverse cosine of that. I just do inverse cosine at the beginning and just do it one statement.
Oh,
But
you
just do, yeah, if you do inverse cosine,
And
that's
that,
stuff.
Maybe it's because I have
because that
one
one
for
has
summer.
our summons, we summon that area.
Here's your
Thank you.
We have to find the area for every triangle.
No. You have to find, if it says solve the triangle, you can find all the side lengths and all the angles. The only time you need to find area is if it says. Find the area. It's the only time you need to do it. Anybody else need help? Let's get started. Again, most of the time it's calculator stuff in this section. That's why I need to come around and help you out more individually than on the board. But okay, I will check back again here in just a bit.
So,
Yeah.
is this sheet number 59?
Yes, that is 59.
Thank you. Is this due yet?
I will have you turn it in tomorrow after I give you a chance to ask questions.
Okay, thank you.
The formula here, that's supposed to be a subtract. Minus the simple square. Get plus. Let me see that.
Well, did you check your answer to this one first? You should go back and look and see if that one's right. If you're doing something wrong on the first one, we should try to fix it before you keep going.
Oh, sorry. Oh, you did plus again. Oh, you just, it's supposed to be minus. Yeah. I'm saying that, I can't make it negative. You should.
So those are looking okay? Okay. Then what are you concerned about on the next one then?
I'm trying to find A, but the answer I saw is way too much, like 400.
Okay, well that can be okay, depends on the other numbers. What numbers do they have in number 9?
I got the sign, it says a 15.
Oh, okay, that does sound big then. Then you remember the square root?
Yeah, right, sort of big deal. Negative, right over, yeah.
Okay, let me see how to do that. 15 squared right here. You got 15 squared times 12 squared, which should be 15 squared plus 12 squared. That's a plus.
Okay.
Sorry, I typed it in. And you're in the back, so see if that matches up. Number 9, what do they have for A? Okay, something else is open too. Cosine of 20. That angle is only 20.
That's 7. 17's even here.
Okay, so if we're trying to find A, I need to see the original numbers. Trying to find A, we need 15 squared plus, I don't know. This side should have been 30, not 12, it should be 30. I think maybe you were looking up here at this question, so it's down here. Is that what they have for A?
Yeah.
Okay, so that's all it was, just little things. See how you typed it in.
So I did,
We'll just hit second enter. Yeah, it goes up the last thing you did. Okay, and then do second enter before that.
so,
To wherever.
so what I did was I kinda added these,
Okay.
subtracted obviously, and then divided that by the sum of this.
Okay, the problem is this stuff doesn't equal angle A. This stuff equals the cosine of A.
Oh.
So that number's gonna come out something between -1 and 1. You still need to do inverse cosine before you get that price.
Okay.
But again, that's why I do it, I just do it as, in the very first step, so that I don't have to worry about it.
Gotcha.
No, because those lines are parallel. But these two, since this is a straight line, yeah, because it's half the circle, so then that's it.
Thank you.
Anybody else have a question or two ready to go? I can come over and help.
So I typed this in, and every time I do it, it's like error, and I'm not changing small things. But
You shouldn't have to put all those in parentheses.
I should have.
It doesn't hurt anything, but it's fine. You know, I mean, it's not gonna hurt anything, so.
Okay.
Hold on, let's squeeze. Okay, so you've got. Okay, that looks fine. What are you trying to find? Side lane?
Trying to find, sorry.
Okay, it is a syntax error, so I think the problem is, I think you had one too many parentheses at the end. It's confused.
Oh, thank you.
Yeah, but you might make sure that number's still right. Sorry?
Say something and say, you know, that's it again.
I still don't. What did you say?
Say like an answer or something like that.
Oh, okay, the store button down here, right above the on. Okay, so it does a little arrow, and then you need to type in whatever letter you wanna store it in.
Okay. Thank you.
Just leave a marker over there. Thank you. Just leave the marker over there. don't have these numbers plugged in, right?
Okay.
So I'm just looking at yours. 15 squared minus 15 squared would be 0. So your numerator's 30 squared.
Right, but
Down here, you got 2 times 15, which is 30, times
Okay.
30, which is 30 squared.
yeah.
So all that's going to 1.
Okay.
So if you're trying to find angle B, this should be A squared
Did I? Is this correct?
plus C
It is.
squared. Are you sure these numbers are right?
Mm-hmm.
Oh, okay, wait, maybe it's
Maybe
this
that's
one.
wrong.
Let's see, if you're trying to find A, you need to take B squared plus C squared minus 2AB cosine C. This is what I'm getting for A.
Okay.
And you're missing the cosine here.
Oh, okay, okay. Thank you.
You're still missing a side. This is B squared, square root of B squared plus C squared minus 2BC. You need a 30 in there. Cosine of the opposite. Right, I don't know, I'm guessing on the letters, but you're still missing part of that formula.
Can I see your calculator? What you just put in? 30.
I just know the, because I know the formula that you square side here plus square side here minus 2 times those two sides again, and you only had one of them. There, now it looks okay.
So whatever this last number is, you cosine it again.
That's the end of the formula wants a cosine of the angle opposite the side you're trying to find.
Okay, okay.
Oh yeah, we didn't talk about that one together. Let's skip that one for a second. Go on to the next one. Yeah, sorry, I forgot. We will need to talk about, there's one thing in number 52
That we'll need to talk about, so.
let me give everybody about 5 minutes.
And then we can do question 52 together. So in the meantime, just skip it.
Try to find a stopping place in 2 minutes so that you can go over 52 with me.
I just have a question about how to solve this. Is this the correct way to go about solving for side A? This question.
Square root of squared plus c squared minus 2a 2bc equals. Yeah, that's fine.
Okay. I didn't know if there was something else because it was. How should I kind of copy that answer in? Because I just typed it on that, but I know in some other occasions it might have like a repeating decimal.
Well, you can store it with this, and then what was this, A?
Okay. Yes, sir.
So I would do alpha A, and then anytime you do A, it knows exactly what you're talking about.
Okay, gotcha.
Until you overwrite it with something else.
Okay. Thank you.
Okay. Let's jump ahead to number 52 here. I guess if you really don't want to jump ahead to 52, you can pull up the class recording later, but I would prefer you to kind of get it knocked out right now. What's a little bit different about 52, there's one little thing in there that I haven't shown you yet, and it's a type of bearing. And we did some bearings last semester, but the type of bearings we did gave you directions. It would be like, I don't know, start on the south line and turn 24 degrees towards the west line. And that's fine. That type of bearing is a bearing. But sometimes they don't give you directions, like in 52. And so on a bearing, if it doesn't give you these directions, what line to start at and what line to turn towards, you need to assume that you start at the north line. If there's no directions, it's assumed you're starting at the north line and you're turning clockwise. So to show you what your picture should look like with 52, because you actually have to draw on these bearings. It's about a plane that flies to a couple cities. So we've got a plane that flies 810 miles from Franklin to Centerville, and it takes a bearing of 75 degrees, which means from the north line, turning clockwise 75 degrees. Like that. So again, they didn't say north towards east, it just said a bearing of 75. But if it doesn't give you directions, start at the north line, turn clockwise, which is towards east. Okay, and then that gets you to a different city. Let's get us to Centerville, and this was 810 miles. Okay, and then it flies another 648 miles from Centerville to Rosemont, and it takes a bearing of 32 degrees. So now from Centerville, I need to take a bearing of 32, which would mean from the north line, turn 32 degrees clockwise. So that would put this to be about 32. And that gets you to the third city, Rosemont. This question wants us to, so that's the part you need to make sure you update on your paper here. It's just an important type of bearing. No directions, north line measured clockwise. But what they want us to figure out in this question is how long or how many miles would it take if we just went straight and didn't detour to Centerville. If we just went straight there. And what bearing should we take? So from the north line, how much should we turn clockwise to head that direction? So, I don't know. Of course, there's a lot of different ways you can look at this. You see this 75 represents all of this. Personally, anytime I hear bearings, I know I'm going to have like north-south lines, which are guaranteed to be parallel. And then just like last semester, if you've got two parallel lines, you can think of any line that intersects them as a transversal. And so personally, I would steal this 75 that is in the interior top left, and he would alternate in the interior bottom right. Again, it's not the only way to do this, but for consistency, I always said angle side angle, or alternate interior angles. And the reason why this is helpful is now these make up half a circle. So if I know this much of it's 75, this must be 105, because together half a circle should be 180. Now I'm thinking about law of sines or law of cosines. If I'd like to know this side, well, actually what I have here is I have a side length. Next to it I have an angle. Next to it I have a side. Side angle side is law of cosines. So I can use this information to find this angle, or this side. So I'm going to call this side A. So A would be the square root of one of the other lengths squared plus the third length squared minus 2 times this length times the cosine of the angle in between those, which I figured out was 105. And that's your first answer. That's going to tell us how many miles it would be if we went straight from Franklin to Centerville instead of detouring to, Franklin to Rosemont instead of detouring to Centerville first and then to Rosemont. I'm getting about 1,160.906 miles. Okay, but they also asked us to find the bearing. So the bearing is going to be from the north line, measured clockwise, this. If I can figure out how many degrees this is, this will be the bearing. Now, you might be able to go about this another way. But what I realize, and again, I know my picture is very busy now. It may have helped if I had started with a bigger picture. But at this point, I know 1, 2, 3 sides. So that's side, side, side. And law of cosines can be used with side, side, side to find an angle. So I'm going to use that to figure out how big this angle of the triangle is down here at F. Because I know this whole turn was 75, and the bearing is going to be 75 minus whatever this little bit is. So to find this angle F, I'm going to plug these numbers into the law of cosines formula that gives me angles. So that would be like what I called side A squared plus 110 squared minus the 648 squared. If it bugs you, if you're not sure which one of these is A, B, and C, you can always just rename these. Make this be A, B, or C, make this be A, B, or C, and make this be A, B, or C, and then you can match it up to the formulas. And then that one should be ready to go too. That's about 32.627 degrees. Again, that's this little bitty angle in this triangle. But if they told me from the beginning that this whole thing was 75, and this is the bearing I want to take, then this answer comes from 75 minus this guy. So the bearing would be 42.373 degrees. Now, if you want to put directions on there, you're welcome to. You're welcome to say north, that much towards east. But again, if you don't say that, and that's really the only reason I'm working this question completely for you, if it's a bearing that does not have directions, north line, clockwise. So if I don't say what my bearings are, the directions, it's assumed I'm starting at north line and turning clockwise, which was what I was trying to find. Now again, I do think there's probably some good value in trying to make that picture again on your own, especially since mine's kind of scrunched up there. Yeah.
Would the angle not be 137 and not to add the 32?
You are correct. This angle wasn't 105, it was this whole thing. Should have been 137. Thank you. Okay, so that actually makes this side a little bit bigger. 1,357.848. And then since that side is bigger, that's going to change this angle a little bit. But again, I had this stored, so it doesn't take me long to just pull up what I already had. So angle F was actually about that. So the bearing part of the answer was 75 minus that. So it looks like the bearing should actually be 56.006. Once again, sloppy picture there. It's kind of hard to know, especially like I'm limited to my screen here, but it's kind of hard to know what your picture is going to look like when you start it with the bearing, which direction it's going. But of course, the bigger you make your picture, the more room you give yourself to kind of see what's going on. But this is the important part. You need to jot this down so that if you need to look back at that and review that, you remember how I set up the picture. Because they didn't make a picture for you on 52. Okay, well for now, again, if you have 60, well you should have 60 done, but if you have 60 and 61 done, go ahead and turn. Forget, but for now we've got about 4 minutes till you're dismissed. So if you need to finish up a couple for homework, then that will be your homework, and make sure you turn those in before I see you tomorrow. I assume we will probably have school tomorrow, so don't wait thinking that it's going to be a snow day. I really don't think it will be a snow day tomorrow. But those need to be turned in before we start class tomorrow. Then on Tuesday, you'll get the review sheet where log signs and log cosines are scrambled together. And next Thursday, we'll have this quiz. Should be on there. Did you check it? I'll have to look and see where I've got those.